Hello and welcome to today's discussion on using artificial intelligence and machine learning technologies and techniques to make the use of application programming interfaces, or APIs, safer and more resilient. I'm Dana Gardner, Principal Analyst at Interarbor Solutions, and I'll be your moderator for our deep dive discussion here and now with Ravi Guntur, Head of Machine Learning and Artificial Intelligence at Traceable AI, the sponsor of this presentation. Ravi has more than 15 years of experience leading technically focused teams and for research and product development. He has practical experience in using pattern recognition, machine learning, and mathematical optimization techniques to solve business-critical problems involving text, video, as well as security log data. He has been granted 16 patents and has delivered more than a dozen peer-reviewed research papers. After my brief introduction to today's topic and my interview with Ravi, we welcome your questions for an in-depth interactive session with Ravi, and we'll directly address your concerns and questions around improving API security. While the use of AI and machine learning for IT security may not be new, the extent to which data-driven analytics detects and thwarts nefarious activities is still really in its infancy. And nowadays, an expanding universe of interdependent APIs forms a new and complex threat vector that strikes at the heart of digital business and all business, really. So how will machine learning and AI form the next best security solution for APIs across their dynamic and often uncharted use across these business processes? We're now going to answer that question by exploring how advanced big data analytics forms a powerful and comprehensive means to track, observe, understand, and model safer APIs creation and use. To learn how API security forms a new killer use case for advanced data science capabilities, please join me in welcoming Ravi Guntur, Head of Machine Learning and Artificial Intelligence at Traceable AI. Now, please do use the interface that you're viewing right now to add your questions during our 20-minute interview. We will address them all at the end of the discussion. And now, on to my interview with Ravi.
Why is API security such a perfect use case for the strengths of machine learning and artificial intelligence? Why do these come together so well?
When you look at the strengths of machine learning, the biggest strengths of machine learning is the ability to process data at scale. And monolithic applications have taken a new avatar, so to speak, which is in the form of API-driven applications. So large pieces of applications have been broken down into smaller pieces. And these smaller pieces are being exposed as smaller applications in themselves. So in order to process the information which is going in between these applications, in order to monitor what activity is going on in these applications, the scale at which you need to deal with them has gone up manyfold. And I think that's the reason why machine learning algorithms would form the best suited class of algorithms to deal with the kind of challenges that we face with API-driven applications.
All right. Well, given the scale and complexity of the app security problem, what makes the older approaches to security wanting? Why don't we just scale up what we already do with security?
So I like to give an example or an analogy as to why older approaches don't work very well. So think of the older approaches as a big box with, let's say, one single door. And for attackers to get into that big box, all they had to do is they had to crack through that single door. Now, what we have done is we have broken that big box into multiple small boxes, and we have given a door to each one of those small boxes. So if an attacker has to now get into the bigger application, the attacker now has to get into each of these smaller doors. And once he gets into one of these smaller boxes, he needs to take a key out of it and use the key to open another box. So what has happened is by creating the API-driven applications, we have actually exposed a bigger attack surface. That's number one. Number two, we have made it challenging to the attackers as well. But the attack surface being bigger now needs to be dealt in a completely different way. The older class of applications looked at rule-based systems as one of the common approaches to solve security use cases. And because you just had one single application and the application would not change that much in terms of the interfaces that it exposed, you could actually build rules in order to analyze how traffic goes in and out of that single application. Now, the moment we broke the application into multiple pieces and we brought in other paradigms of software development, such as DevOps and agile development methodologies, What this has created is it's created a scenario where the applications are rapidly changing. So there is no way rules can catch up with this rapidly changing applications. We need automation in order to understand what is happening with these applications. And we need automation to solve some of these problems which rules could not do with the older systems.
So we really shouldn't think of AI here as replacing old security or even humans. It's actually doing something that just couldn't be done any other way.
Yeah, absolutely. So there's no substitute for human intelligence, and there's no substitute for the thinking capability of humans. If you go deeper into the AI-based algorithms, you'll realize that these algorithms are really very simple in terms of how the AI is powered. So they're all based out of optimization algorithms. And optimization algorithms really don't have this thinking capability. They don't have creativity, which humans have. So there's no way these algorithms are going to replace human intelligence. They are actually going to work alongside humans. They're going to make all the mundane activities easy for humans and help humans look at the more creative and the difficult aspects of security, which these algorithms can't do out of the box.
Another significant security threat are bots, and maybe not just humans, but the scale that the threat vector takes when it comes to use of bots. Is that something that only automation can rely on, or is it the best combination of human and machine to ferret out these bots and other sophisticated means that folks are using?
So usually what we have seen is most of the detection cases that we see in the field of security is a combination of humans and machines. Now, you're very right in the sense the attackers are also starting to use automation in order to get into systems. So we have seen such cases where the same bot comes in from geographically different locations and is trying to do the same thing in some of our customer locations. Now, the reason why they're coming from so many different locations is it basically acts as a challenge to AI-based algorithms. So one older school of algorithms would look at rate anomalies. So they would see how quickly somebody was coming from a particular IP address. Now, the moment you spread the IP address across the globe, you really don't know whether it's different users or it's the same user coming from different locations. So these kinds of challenges have been brought on by attackers by using AI. Now, the only way to challenge that is by building algorithms to counter them. One thing's for sure, algorithms are not perfect. Algorithms do create errors. Algorithms create false positives. And that's where the human analyst comes in to really understand whether what the algorithm discovered is a true positive or it's a false positive. Now, by going deeper into the output of an algorithm, digging back into how exactly the algorithm figured out that something was a bot, is going to give insights into exactly how an attack is being launched. And some of these insights can't be discovered by algorithms. Only humans, when they correlate different pieces of information, they'll be able to find it out. It's a team, I would say. Algorithms and humans are working together, and that's a team.
And of course, we see the use of machine learning and AI in lots of aspects of IT and security. What makes the way in which Traceable AI is doing this different? Why are you unique in your vision for AI, but also in the execution and how you're using it, particularly around APIs?
So when you look at any AI-based implementation, you'll see that there are three basic components. The first component is that about the data itself. It's not enough if you capture a large amount of data. It's not enough if you capture quality data. Most cases, you cannot guarantee data of high quality. There'll always be some noise in data. But more than volume and quality of data, I think what is more important is whether the data that you're capturing is relevant for the particular use case that you're trying to solve. So is the data that you're capturing helpful in solving security use cases? So what Traceable did was it kind of built this platform, which was built ground up to cater to security use cases. So right from the foundations, we started looking at the specific type of data which is required in order to solve modern API-based application security use cases. So that's the first challenge that we address. And I think that the way we built it ground up, I think it's very important. And I think that's what adds strength to the product. Mm-hmm. Now, once you address the data issue, the next issue is going to be about how are you going to learn? What are the challenges around learning? What kind of algorithms do we use? What is the real scenario when we deploy in a customer location? So we realized that every customer location is going to be completely different. Every customer has completely different set of APIs. The APIs behave completely differently. The data that goes in and out is very different. Even if you take two e-commerce customers, they're doing the same thing. They're basically allowing you to look at products and they're selling you the products. But the way the applications are being built, the API, everything is different. So we realized that it's no use to build supervised approaches. We need to come up with an architecture where the day we deploy it at the customer location, the algorithms self-learn. So the whole concept of being able to learn on its own just by looking at data is the core to the way we build security using the AI algorithms that we have. And finally, when you look at once you cover the data and the kind of environment in which we need to work, the last step is to look at how exactly are we going to deliver security use cases. So what is the philosophy behind building a security product? We realize that rule-based systems are not going to work. So then the alternate system that you have is basically modeled around anomaly detection. Now, anomaly detection is a very old subject, and we have used anomaly detection in various things. We have used it in understanding whether machinery is going to go down. We have used to understand whether the traffic patterns on the road is going to change. We have used the anomaly detection in security. But within anomaly, the class of anomaly detection algorithms, we focused on a class called behavioral anomalies because we realized that APIs and the people who use the APIs, which are the users, are two key entities in the system. And we need to model the behavior of these two groups. And when we see any deviation from this behavior, that's when we'll be able to capture the notion of an attack. Now, the reason why behavioral anomalies are more important is because a modern attack, if you look at those attacks, you'll be surprised. They're so subtle. You just can't find the difference between the normal usage of an API and an abnormal usage. But very deep inside the data and very deep inside how the APIs are interacting, there is a deviation in the behavior. And it's very hard for humans to figure this out. And only algorithms can tease this out and say that this behavior is different from this known behavior. So when you look at it as a stack, we have addressed this at all levels of the stack, at the data capture level, at the choice of how we want to execute our AI, and the choice of how we want to deliver our security use cases. And I think that's what makes it unique and holistic. We didn't just bolt things on, we built it ground up. And that's why I think these three pieces gel well and work together.
I'd like to revisit the concept that you brought up about the contextual use of the algorithms and a multiple number of algorithms being deployed because this is sort of a moving target and it's so different use case by use case, company by company. How do you keep up with that change? How do we remain contextual? Is there a way that you perhaps track specific APIs and see a pattern over time? What are some of the more intricate factors in making contextual behavior pattern analysis remain relevant throughout the lifecycle of an API?
Yeah, that's a very good question. So the notion of context is very abstract. So, but when you dig deeper into what exactly context is and how exactly you build context, it boils down to basically finding all factors governing execution of a particular API. So let's take an example. So let's say we have an API and we're looking at how this API is functioning. It's just not enough if you look at what was the input of the API and what was the output of the API. We need to look at something around it. We need to see who triggered that input. Where did that user come from? Was it a residential IP address that the user came in from? Was it a hosted IP address? Which geolocation did the user come in from? Did this user have past anomalies within the system? So we need to bring in all these factors into the notion of context when we're dealing with API security. Now, it's a moving target. So the context, because APIs are constantly changing, data is constantly changing. What is not changing is this context. So the moment when you have fixed this context, when you say that, we know where the users are coming from, we know what the users have done in the past. So there is some amount of determinism that we are adding to whatever detection that we are performing on these APIs. The reality is the inputs to the API, let's say an API takes in 5 inputs and it gives out 10 outputs. So the 5 inputs and the 5 outputs are constant for every user. But the values which go into the input varies from user to user. So your bank account is different from my bank account. So the account number which I put in there is different for you and it's different for me. So if you build an algorithm which looks at anomaly, it will say, hey, you know what, this particular field, I'm seeing so many different bank account numbers. So there's some problem with this. But that's not true. It is meant to be having large number of variations in that account number. And that comes in from context. So building this context engine is something unique into our AI-based system. And that helps us tease out these false positives and helps us learn the fact that some of these variations that you're seeing are genuine variations. So that's how we keep up with this constant changing environment, where the environment is changing not just because new APIs are coming in, it's also because new data is coming into these APIs.
Is there a way for the algorithms to learn more about what makes the context powerful to avoid false positives that you're finding in your trials and in your initial deployments? Is there certain data and certain ways perhaps that people either use APIs or design the APIs that allows your model to work better?
Yeah, that's a great question. In fact, when we initially started off, we thought APIs are well designed. We thought an API is a small unit of execution. And when developers roll out these APIs, they'll all be focused on very focused piece of execution within these APIs. But soon we realized that developers start bundling various additional features within the same API. We started seeing that they just provide a few more input options. And by triggering those extra input options, you get completely different functionality from the same API. So we had to come up with algorithms which can actually discover the fact that this particular API can behave in multiple ways depending on the inputs that are being transmitted. So we realized that it's difficult for us to figure out that whether the API is going to change or not going to change. But when we built our algorithms, we assumed that an API is going to have multiple manifestations. And we need to figure out which manifestation is currently being triggered by looking at the data. We kind of solved it differently by kind of creating multiple personas for the same API. Although it looks like a single API, we have an internal representation which kind of represents this API in multiple personas.
Interesting. Another thing that's fascinating to me about the API security problem is that the way hackers can get in there is to not try to abuse the API, but you have subtle logic abuse attacks where they're basically doing what the API is designed to do, but using it as a tool for their nefarious activities. So how does your model and how does machine learning and the algorithms and modeling that you're doing help fight against these subtle logic abuse attacks?
So when you look at the distributed applications and APIs and the way hackers are getting in using these attacks, which are so subtle, we usually classify these kinds of attacks as business logic abuses. So what they're basically doing is they're using the existing business logic, but they are abusing it. Now, figuring out abuse to business logic it's a very difficult task. It actually involves a lot of combinatorial issues that we need to solve. So when I say combinatorial issues, I'm basically meaning that it's a problem of scale in terms of the number of APIs, in terms of the number of parameters that can be passed, and the types of values that can be passed. When we built the platform, we realized that it's just not enough if you look at the calls that are made to the front-facing APIs. We call them the external APIs. It's also important for us to go deeper into the API ecosystem. So we have two classes of APIs. One we call as the external facing APIs and other is the internal APIs. So the internal APIs are not called by users sitting outside of the ecosystem. They're called by other APIs within the system. So the only way for us to figure out these subtle logic attacks is to be able to follow the paths taken by those internal APIs. So if those internal APIs are going and reaching a resource, like for example, it reaches a database, and within the database, it reaches a particular, let's say, a particular row and a particular column, and then returns the particular value. Only then you'll be able to figure out that there was a subtle attack which took place. And we'll be able to figure this out only because of the ability to trace the data deep into the ecosystem. If we had done everything at the API gateway, if we had done everything at external facing, you would not have figured out that there was an attack which was launched, which went so deep into the system and it touched a resource which it should never have touched. So it's all about how well you capture the data and how rich is your data representation in order to capture these kinds of attacks. And once you capture this tons of data which you have, and especially graph kind of data, you have no option but to use algorithms to process it. And that's where we started using graph-based algorithms in order to discover variations in behavior, discover outliers, and discover the patterns of outliers and so on.
It strikes me in listening to you that in order to tackle this problem, you need to know a lot about data and integration, a lot about security and the vulnerabilities, a lot about algorithms and artificial intelligence and data science. Tell me about your background. How is it you're able to sort of keep these big multiple balls in the air at once when it comes to solving this problem? There's so many different disciplines involved.
Yeah, so it's been a journey for me. When I initially started off way back in 2005, I just graduated from the university and I'd used a lot of mathematical techniques to solve some key problems in natural language processing. But as part of my thesis, I also realized that even security use cases can be modeled as a language. So if you take any operating system, we typically have a few system calls, right? About 200 system calls, or maybe 400 system calls. So all the programs that are running in these operating systems are using these 400 system calls in different ways to build these different applications. So it almost is very similar to natural language. In natural language, you have words and you compose the words according to a grammar in order to get this meaningful sentence. So something similar is happening even in the security world. So that's when we realized that we could apply some techniques from statistical natural language processing into the security use cases. And we were able to discover, way back then, we were able to discover certain Solaris login buffer overflow vulnerabilities. So that's when the journey started. But then I realized that as I went through multiple jobs and working in different kind of use cases, that if you want to be a good data scientist or if you want to use machine learning, you should think of yourself as something like a carpenter, somebody who has a toolbox with lots of tools in it and knows how to use those tools very well. But in order to use those tools, you actually need to build various things. You need to build a chair, you need to build a table, you need to build a house. So you need to build various things using the same set of tools. And that took me through a journey. So I started with natural language processing, then I went to image processing, then I went into video processing, and then came into security. And so it was a journey. And through the process, what happened was we started to realize that almost all problems can be mapped to a canonical form. You could take any complex problem and break it down into some simple problems. And almost all fields can be broken down into these simple mathematical problems. And if you know how to use those mathematical concepts, you'll be able to solve a lot of different problems. And I think we are kind of applying the same principle at Traceable as well. So yeah, it's been a journey. And every time you look at data, you come up with different challenges. And the only way to overcome that is to kind of dirty your hands and kind of solve it. And I think that's the only way you would learn. And that's the only way we could build these new class of algorithms by taking a piece from here, a piece from there, putting it together, and then building something else.
That's fascinating. And to your point of so many difficult things in nature and in business and in technology can be brought down to an elemental mathematical understanding. When you've attained that with these APIs, for example, in business services and data, we're applying this first to security, and rightfully so. It's an essential problem, the low-lying fruit, if you will. But over time, it seems to me that you'll also get mathematical insights and understanding of more about how microservices are used, or how they could be optimized, or architectures could be optimized, or how the relationship between developers and the production crew might be optimized. So is that what you're setting the stage for here, is a mathematical foundation that can be brought to a much greater and potentially productive set of problem solving?
Yeah, you're right. So if you've been thinking about it, and we have kind of started on the journey already. So when we look at what we have achieved as of today, and we look at the foundations over which we have built, we see that we have something for everybody. We have something for the security folk. We have something for the developer folk. And we have realized that the system that we have built kind of gives insights to developers as to what happens to their APIs when they're in production. Usually the development team just doesn't know what happens to their APIs when it's in production. How is it behaving in production? How many users are using these APIs? How are they using it? They have no clue as to what's happening there. And on the other side, the security team doesn't know exactly what this application is. They can see lots of APIs, but how are these APIs all glued together to form this big application? Now, the mathematical foundation under which all these implementations are being done is based on relationships between APIs. You can call them graphs, you can call them sequences, but it's all about relationships. One aspect which we are looking at is how do you expose this relationship? We are today having this relationship buried deep inside our implementations and inside our platform. But how do you take it out and make it visual so that they understand what happens, what is this application, what happened to our APIs? Now, by looking at some of these things in the visual form, you'll be able to figure out various things like, are there bottlenecks within our application? Is this one API constantly hit? In order to, if you want to make it, if you want to complete my, let's say, my card checkout, I always go through this API. But the same API is also leading me to the search engine. It's also leading me to, let's say, my products catalog page. So why is it this API needs to go through all of these? So can I simplify that API? Can I break it down and make it multiple pieces? So this kind of insight is being made available to the developer community.
For those that are listening or reading this interview, how should they prepare themselves for being better able to leverage and take advantage of what Traceable AI is providing? And that would be for both the developers as well as the security, as well as the operators. What should they be thinking or doing now in order to be in a best position to leverage what you all are producing?
So the moment you deploy Traceable in your environment, the algorithms kind of start kicking in and they start learning about the patterns of traffic in your environment. So within a few hours, if your traffic has a high volume, or within 48 hours, if you have low volume traffic, you'll get an insight as to the API landscape within your environment. You'll get to know how many APIs are there. That's, I think, one of the fundamental problems that a lot of companies are facing today. They just don't know how many APIs are there. Once you know how many APIs are there, you get to figure out how many services are there. What are these different services? Which API belongs to which service? So it gives you an entire landscape within a few hours of deployment. So once you understand your landscape, the next interesting thing that you'll see in our user interfaces and all of that is how risky are our APIs? So are we exposing sensitive data? Are we, how many of the APIs are external facing? Have we used authentication in order to give access to our APIs or not? And why some APIs do not have authentication? How are we exposing APIs without authentication? So all these questions are answered right there in the user interface. So just have to eyeball and just see, and you get to figure all these things out. Once you have done these pieces, you can also look at whether your development team, the spec which the development team said complies with whether the APIs comply with that particular spec is true or not. Because usually what happens is the development teams are rapidly churning out code. They never maintain the API spec. So they will have a draft spec and they will build against it. But finally, when you deploy it, the spec looks very different. But who knows it's different? How do you know it's different? So the insight as to whether your spec is compliant or not, you get to see right there the moment you deploy within a few hours of your deployment. In addition to knowing what happened to your APIs and whether they are compliant with the spec or not, you'll start seeing various behaviors. Usually people think that when you have, let's say you have about 100 APIs which are deployed, all users use the APIs the same way. So suppose I have a mobile app, my banking app. And when I log into my banking app, there's a few APIs which I call unconsciously, right? I don't know, I'm just pressing buttons. So we think all of them use the app the same way. But in reality, you'll be surprised to see that users use these apps in so many different ways. Sometimes the APIs are accessed through computational means. Sometimes they're accessed through user interfaces. So there is insight to the development team in terms of how users are using your APIs, which itself is a great insight, which will help you build better APIs, which will help you build a better application by simplifying your application deployments. So all these are available to you within a few hours of deployment. And I think that's what is very exciting. So when you just deploy it and then open the screen and look at all the information which is out there, it's just fascinating to see how different companies have built their ecosystems.
Well, great. Thank you for that in-depth look at the AI and machine learning aspects to security, particularly API security. We're now live with Ravi Guntur to take your questions. Are you ready, Ravi?
Yeah, go for it.
All right. I'm seeing a question from our audience, and it's, does the AI and data science to protect APIs have to come from within our organization? We don't have a lot of API or AI experience, rather, especially with our developers?
No, not at all. So what we do at Traceable is to use artificial intelligence, machine learning, and other classes of algorithms to process data. So you don't have to really worry about what algorithm runs, or you don't have to worry about tuning the algorithm. You don't even have to worry about trying to train the algorithm or change the algorithm. So all of that is taken, is all executed transparently for you. So you don't have to worry about the AI experience or expertise. So what you really need to be worried about is, or look into, is what do you do with the results that Traceable produces. So you may want to have some actionable outcome out of it. You may want to take some decisions based on the events that you're seeing and so on. But you really don't have to worry about the algorithms that we use or how to tune them.
So it's almost API, big data analytics, security as a service. Is that correct?
Yeah, it's more of a service. Yeah, it all gets done behind the scenes.
All right. Another question from our audience. We already have a lot of security tools for our applications, networks, and developers. Why do we need to add machine learning and AI too?
So if you go and price open all your tools and appliances and implementations that you have, in reality, what is running behind the scenes is algorithms. So whether we use classical computer science algorithms or whether you use the modern day machine learning or AI based algorithms, it doesn't matter to you. So it's not about why we need AI or why we need machine learning. It's about, you have no choice but to use those, because the volume of data that you're trying to process, the detail at which you're capturing data, there's no way some of the legacy tools and applications can handle that kind of data. So it's all about how do you handle the data and what algorithms you use to handle the data. So we cannot really say why we need ML or not need ML. It's about, what is the class of algorithms do you use in order to solve these kinds of problems. And modern day volumes of data and the veracity that we have no choice but to use some of these machine learning algorithms.
I'd like to add a follow-up to that myself. What is it about the web application firewalls and other application-specific security, you can think of it as the legacy security tools, that is inadequate for what we're describing around API security?
Yeah, so the traditional tools that we have, especially the WAFs, they were all built out of a with the mindset of signature recognitions and signature detection. So what you had with endpoint security, the concepts that you had in endpoint security, you brought that into the WAF world as well. So first thing which you see is WAFs basically deal with stateless detection. That means they look at point observations and then apply rules on that observation and then say whether there's an anomaly or not. But modern day attacks that we are seeing are not so simplistic. The business logic attacks that we see, they actually involve a combination of APIs. That means there is something stateful about what is happening with those APIs. And the moment we start dealing with the stateful nature of data, it's not enough if you use rules, because there's no way you can manually create these rules and say that, hey, if API 1 talks to API 2, and then if this data is so and so, then you create an alert for me. The data is changing, the APIs are changing, the way APIs talk to one another change. So there's a lot of dynamic activity that is going on, because of which rules can't work, and hence WAFs really can't help you. So the second thing is, WAFs typically work at the edge, whereas if you want to really have very low false positives and you really want to capture these subtle attacks, you need to go deep into the system. And that is where Traceable has come up with this concept of using tracing in order to identify these kinds of attacks. So whenever we deal with tracing, we are actually dealing with graphs, and processing graphs, having to deal with graphs, all of these cannot be done with signatures or rules. And I think that's where uh, the WAFs kind of served their purpose, but you need to move on as the newer class of attacks come into play.
All right, here's another question from the audience. In case of any API vulnerability detection, what will be the course of action from Traceable? Metrics, observability, or custom policies for subsequent action?
Yeah, that's a great question. So, first thing is we are still early in our journey. We have certain pieces of our implementation that we have provided for customers. So if you look at the user interfaces, and you're welcome to try out the free version which we have put up. But if you look at our user interfaces, you'll see that the core of the Traceable platform is to surface those critical events for you. So once you have those critical events surfaced out for you, like we surface out the kind of attacks that we have detected, we surface out the users who are responsible for those attacks. Now, given the fact that you know who the users are, you could actually block activities of the user. You could block all the activities of the user. You could say this particular user, let's say Ravi at Traceable AI, you block all activity from this user. So even if this user comes in from different IP addresses, different geolocations, you're able to actually block that particular user. So that's one action that you can effectively take. The second activity that you could do is you could try to understand the modus operandi of these attacks. We have a very good data lake. So we have a search interface which will help you slice and dice through the deep tracing data that we have captured. So by looking at this attack and then going back and analyzing these deep tracing data that we have captured, you will be able to kind of understand how exactly the attacker acted within the system. And based on that, you could take actions as to how to secure your APIs. You could take actions as to what are the typical activities that these attackers are doing that you could plug at the code level itself. So there is these kind of insights that you can act upon.
And again, I'd like to do a follow up question to that. It seems to me that as you build more data and understanding over time across multiple uses of APIs, and you're using sophisticated AI and machine learning technologies, that you might be able to start offering machine learning developed recommendations for how to improve the situation. Is that going too far with what these capabilities are, or is that another story for another day?
Well, we have not thought of it at the moment. I think it's definitely doable. If you have algorithms which can detect some of these, you could also figure out how to kind of offer suggestions as to how you can improve your APIs. So we have done some research work around these topics, where we have seen we have identified things like critical points in your API connectivity, and those critical points are the ones which really need to be protected by you, so that the attackers don't have access to the larger ecosystem within your API deployments. So at the moment, it's all in the research phase. We have not rolled out anything in production, but it's something that is definitely doable, and it's good for the developer community because something actionable will come out of this.
Suffice to say that, as I pointed out in my introduction, we're only at the very early stages of what machine learning and artificial intelligence will bring to the whole process of API security, but also resiliency and hardening, and having the machines take a more active role in development in total.
Yes, absolutely.
Okay.
Yes.
Another question. If APIs can be hacked, why can't the trail of data around the breaches also be covered up? In other words, why is machine learning any less hackable than other technologies?
Yeah. So the whole notion of covering up the trail, you will see something like this in endpoint security, where you have some kind of a zero-day exploit which is launched, and then there is a dropper which drops a file, and then the file gets executed, and after that the attacker clears out the logs, clears out the file itself which was dropped, and so on. But the whole the attacks which involve APIs, they all work at layer 7. They're really high up in the OSI stack, so to speak, right? So most of the activity here is immutable. So you cannot change the infrastructure itself to to change the logs, or to get rid of your trail. So that is one big advantage you see. So because it's almost like you're following the actor within your ecosystem, and as the actor follows through your ecosystem, you're capturing those logs and you're storing. We don't call it logs, we call them traces. And the only way the attacker can wipe out the trace is to get access to the traceable environment itself and clear out our databases. So we are quite careful around the security of our own databases and all of that. So unless and until they come in there and get rid of the data which we're capturing, there's no way they can get rid of their trace.
All right, moving on to another question. Developers are not used to using data science. How can we make them more open to it? Is there a user experience element to making the analysis more adopted or usable? I think this is a question about your user interface and how developers might cotton to it.
Yeah, so see, the one way to start off with anything related to data science is to think of analytics. So analytics is something that many of the developers are familiar with. So they can start with analytics, and in some sense, data science uses a different class of algorithms to analyze data, right? So instead of using aggregation queries, instead of using the classical group bys and histograms and counts, you're using a different class of algorithms to uh, process the data. So you start with analytics, and you can start slowly moving towards using data science and other newer techniques which are out there. So the other way to look at it is like when you look at from the user experience point of view, right? How do you present the story? So once the data science algorithm has processed the data, you need to talk to the user who is using that data. It's not about what the algorithm did, but it's about what the algorithm produced. So what we have done is we have tried to explain the algorithms which are running in the form of better user interfaces. So if you're familiar, there's a lot of discussion going on around explainable AI. So what we do is so if you want to do explainable AI, you have to go to the core of the algorithm to change it. But that's kind of contradicting the algorithm. The reason why you have AI in the first place is because humans can't understand it, and we want machines to do that for you. But the moment you ask machines to explain themselves, it's not possible because humans understand it differently. So the way we address these kind of challenges is we do it through the user interface by presenting the evidence in the form of data, by presenting the evidence in the form of interfaces which you can use to query the data, do aggregations based on the outputs of the machine learning algorithms. You will start bringing in developers slowly towards dealing with data. So the moment you start dealing with data, you'll gradually move towards data science and other machine learning applications.
And as a quick follow-up to that, Ravi, if I could, it seems to me that different people will want to avail themselves of those analytics in different ways. They could be a developer, an architect, a security personnel. They could be a business process engineer. And as I understand it, your interface allows for sort of a drill down persona customization benefit. Maybe you could explain that too.
Yeah, we don't have a lot of customization at the moment because we are still early on in our in the user interfaces and the design. But we do have a very good capability which we offer where people can drill down into the data using what we call as the traces. So it's basically we have this deep store where we have all the logs all the traces that we have collected, and using various types of queries on the data itself, they can actually do the analysis themselves. Now, the difference between a classical spreadsheet or the kind of numerical data that you have versus traceable is the data that traceable captures is the tracing data. So we have this concept of spans, concept of traces, and then we capture information about what the user agent is, what the IP address is, what is the API that was accessed, what is the request response body looking like. So there's a rich amount of data out there. So using this interface, which we call as traces, you could actually query the deep stores and get the data out and look at the data in terms of the classical interface which most analysts are familiar with.
All right, well, that's the end of our questions, and I'm afraid we're going to have to leave it there. You've been an essential part of this discussion on using AI and machine learning technologies to make the use of APIs safer and more resilient. Our audience has also made this a very powerful discussion. We've learned how advanced machine learning powered modeling forms a powerful and inclusive means to track, observe, understand, and model APIs in action. Please do go to the Traceable AI website, where you'll find many more resources on API security, including news about Traceable's free open source options for tracing and observing your API's use. You'll also find podcasts, blogs, how-to materials, and much more. Lastly, stay tuned for my next webinar discussion that I'll be hosting. This time it'll be with Atlassian's Chief Information Security Officer, Adrian Ludwig. We're going to learn how to create a more security-minded culture at your business or organization. Meanwhile, this presentation with Ravi will be available on demand, so you can revert back to it if you wish, or you can share it with your community, of course. Let me conclude by thanking our guest. We've been here today with Ravi Guntur. He's head of machine learning and artificial intelligence at Traceable AI, the sponsor of this discussion. Thank you so much, Ravi.
Thanks, Dana.
And a big thank you as well to our audience for joining this presentation. I'm Dana Gardner, Principal Analyst at Interarbor Solutions. Thanks again for joining. Please come back next time and pass this on to your security community. Thank you.